Good morning everyone. Welcome to the course called Design and Analysis of Algorithms. This session we are going to discuss some introductory part of design and analysis of algorithms. Before we go to design and analysis of algorithms, what are the topics that we are going to discuss in the coming sessions, and what are the important aspects related to the algorithm we are going to see in this. We have divided the course into 4 different types of COs called CO1, 2, 3 and 4. Each and every CO has its own outcome where we discuss few topics and we'll also analyze what are the outcomes that are available in each and every CO. So let us go through each and every topic of design and analysis of algorithm, and this session will focus on the basic introduction related to design and analysis of algorithms. Before we go into the design and analysis of algorithms, let us see what is an algorithm. Later we'll discuss how we are going to design an algorithm and how we are going to analyze a particular algorithm. An algorithm is a finite set of instructions that accomplishes a particular task. So in order to solve a particular problem, or in order to perform a particular task, we need to follow a set of instructions to fulfill it or to complete it. So that is said to be an algorithm. In your first year sessions, you might have learned an algorithm is a step-by-step process to complete a task. The same applies here, but with some advanced mode we are going to discuss the algorithm. All algorithms must satisfy the following criteria. There are few set of characteristics where each and every algorithm or each and every program has to satisfy. So the algorithm will help you how effectively you can write the program, whether you can write a program or not. Like an algorithm will give you an overall view of whether you can solve a particular problem or not. The first characteristics of an algorithm is input. In your first year, you might have written some programs with or without the input. Few examples without input is you were directly writing a statement in the printf and you are assigning some values to a variable. There are few set of problems where you need to provide the input from the keyboard. Generally to say an input where a 0 or more quantities are externally supplied. Externally supplied is nothing but you are providing an input from the keyboard. There are few certain cases where you no need to provide an input, where you are assigning the values to the variables and also you are writing few statements in the printf. Output is generally whenever you write a program, it must give an output. So at least one quantity is produced. Whenever you write an algorithm or whenever you write a program, it should derive an output. The third characteristics of an algorithm is definiteness. Definiteness gives each instruction is clear and unambiguous. You should not write a particular statement where it is ambiguous. If a statement is ambiguous, no one will understand. So you can say an example, a statement such as add 6 or 7 to x. What do you mean by 6 or 7 to x? We have a variable x where we are assigning a value. If you take a variable called a in your program, you generally assign 10, or where you can assign 20. Means a variable takes only one value, so you cannot assign a is equal to 10 comma 20. If you want to assign more than one value, then you need to go for another set of assigning the values such as arrays. We'll see in the coming sessions. The finiteness. What do you mean by finiteness? If you are writing a program should terminate after a finite set of iterations, a finite set of instructions. There should not be any program which is an infinite iterations. So whenever we are writing a program, make sure our program should have a finite set of steps. The fourth characteristics is finiteness. The finiteness defines the algorithm should terminate after a finite number of steps. Let us say a 6 number of iterations, 7 number of iterations, kind of. The final characteristics of an algorithm is effectiveness. What do you mean by an effectiveness? Instruction is basic enough to carry it out. So you should not provide an instruction which is not an effective in nature. These are some of the areas of algorithms we need to consider. The first is how you devise an algorithm, how you validate an algorithm, how you analyze an algorithm, and there are two different types of test procedures for a program. One, the debugging and profiling. How you devise an algorithm? As we discussed in the introduction in the beginning of the session, so we have different types of strategies to solve a problem. So you can see the first and foremost strategy is divide and conquer strategy. The second one, greedy method, dynamic programming, backtracking, and branch and bound methods, and we have few other methods to solve an algorithm, to devise an algorithm. So if you see all these methods, mainly design and analysis of algorithms mainly solves optimization problems. What do you mean by an optimization problem? Let us say you have a problem P, and each and every problem has different types of solutions to solve. So there is solution 1, solution 2, solution 3, and solution 4. Our task is to pick the best one out of the 4 feasible solutions. When we pick, let us say S2 is the best one, we say this is an optimization solution. We will see the different types of strategies in the coming session. The second is how to validate an algorithm. So to check whether the algorithm giving correct output or not for all possible inputs. In your first year, you have seen HackerRank programs where a set of problem statements are given. And you are supposed to check with the given test cases. So these test cases plays a vital role in solving the problem. Means you got a problem, let us say you have a problem X and you got a solution for the problem called X1. There may be certain procedure to derive, we may get X2 solution also, but out of X1 and X2, one will be an optimization solution, and out of these two, which is satisfying all the test cases, will be an validation of that particular algorithm. So we have two different types of strategies for analyzing an algorithm. Generally we call it as time complexity, categorized as time complexity and space complexity. So whenever we need some amount of time to solve an algorithm, that is considered as the time complexity, and space complexity is defined as how much space is required to hold all the variables in that particular algorithm. We have two different types of strategies to test a program. One, the debugging, and second one, profiling. Debugging is a process of executing a program on sample datasets to determine whether any fault results occur. So debugging, generally whenever we have a problem or error, so all those errors in the program we call it as bugs, and rectifying the errors are defined as debugging. Profiling is nothing but executing a correct program on sample data sets and determine how much time and space required for a program. Let us say generally whenever we are solving a problem, each and every problem will take 0.01 seconds or 0.23 seconds to solve, and in the same way we need to check how many variables like A, B, etc. we are using in that algorithm. So each and every variable that we are defining as per the data type, it takes some space to solve. So the time taken and space taken are considered as the test cases under profiling. So how to represent an algorithm? So we can describe an algorithm in many ways. So you can represent in an English like language, or you can represent with some equations, or we can represent with some flow chart or some graphical representation also you can do. So these are different ways to represent an algorithm, and our ultimate goal is to represent in an pseudocode or using a particular language. So in this subject we are solving our problems basically in C language. If you are interested in Python, or if you are comfortable with any language, you can solve the problems in your known or your comfortable language. So how we represent most of our algorithms using pseudocode? So we start with the comment lines, where the comment lines will help you to represent or to write the name of the program, and we have the compound statements and body of the procedure. And the third point discusses about an identifier begins with a letter, some set of data structures, some types of clear context whether you are using or not, and few variables that you declare which comes under local or a global context. And data types, as I mentioned earlier, we may declare variables in different types of data types called integer, float, char, boolean, and so on. So this is how a sample assignment of the variable can be done. So whenever you are writing a C language, so you generally do a is equal to 10. So 10 is the value which you are assigning to a. But whenever you are representing an algorithm, so this is how you represent an expression. Like the same statement what we had written, a is equal to 10, can be represented in a colon is equal to 10, or if you are writing an equation, a is equal to b plus c, or sum is equal to a plus b, that has to be represented sum colon is equal to a plus b. So this is how you assign the values to the variable. And we have few Boolean values whenever we represent an expression, either it gives a true or false statements. Whenever you need to represent more than one variable, you need to represent in an array, and arrays generally represented as a of 10 in our programming language, where here one dimensional array will be represented with a of I, and two dimensional in a program we generally represented as a of 10, 20 kind of, but here you will be representing with a of I comma j if you have two dimensional array to be represented. So these are the looping statements, how we write a looping statement in an algorithm. This is a sample while condition, how we represented in an algorithm. So you can see while holds a condition, while, for an example, while I less than 10. If I value is less than 10, the loop iterates with a set of instructions that we give. And general form of for has to be represented with for variable colon is equal to value L 1 to value 2 step 2. Like generally we represent for I is equal to 0, I less than n, I plus plus. So here we represent for I colon is equal to 1 to n step 1 do. So each time it will be incremented with 1. So this is a general form of repeat until loops and few conditional statements of the expression. So the conditional statements are represented like this: if condition then statement, or you can also represent if condition then statement else block. This is a general simple if condition, and this is a if else compound statement. The procedure or a function starts with the word algorithm generally. So algorithm name, let us say we are writing algorithm with an example algorithm sum of a comma n. So these are the parameter list. A stands for array, A stands for array, and n stands for the number of elements in the array A. And you can represent sum is equal to sum colon is equal to sum plus A of I. It iterates for till nth value. So that you represented in the body of an algorithm. So this is a sample algorithm which is available here, algorithm sum a comma n. You can either represent a as a capital or small. S is equal to 0. Initially the sum value is 0 and loop is iterating from 1 to n. Do what it has to do? It has to increment the value I, and each value has to be added to variable s. And finally what we are returning? We are returning s, which is a sum value we are returning to the algorithm. So these are some set of sample questions from the same session. So you need to work on these questions. If a particular question was asked for a short answer, medium answer, or an essay answer, you should be you should practice how you solve the problems. So explain importance of an algorithm to solve real world problems. Like the first example what we discussed, characteristics of algorithm. So we have 5 different characteristics. What are they? Input, output, definiteness, effectiveness, and finiteness. Difference between algorithm and a program, and the concept of recursion in an algorithm. What is an algorithm? The brief definition. Effectiveness of an algorithm, finiteness in algorithm, how many ways you can describe an algorithm, steps to include writing an algorithm, how you validate an algorithm, and how you analyze an algorithm. So this is all about the session 1. Thank you. We'll meet in session 2.